All right, for 4.6 is triangle congruence CPCTC. This is basically, once you are good with 4 and 5, section 4 and section 5, this is just taking one more step into your proof and making it a little more difficult. So yay for that. The objective is to use CPCTC to prove parts of the triangles are congruent. That's your. So your first buzzword is CPCTC. It just basically stands for corresponding parts of congruent triangles are congruent. So if I do my little proof and I show that this is congruent, these two triangles are congruent because of HL. So the hypotenuse is given, the legs are reflexive. So this is congruent. I could say triangle 1 is congruent to triangle 2 because of the HL. Now, what CPCTC tells me is once you've proven the triangles are congruent, then you know every other part of it is congruent as well. So now I can say this angle is congruent to this angle because of CPCTC. This angle is congruent to this angle because of CPCTC. This side is congruent to this side because of CPCTC. So let's do some examples. So real quick though, first, write this down. SSS, SAS, ASA, and AAS and HL use corresponding parts to prove triangles are congruent. So you're going to do the proof as you normally would, using one of these 5. Then CPCTC takes it one step further to prove corresponding parts are congruent. So again, you have to use side, 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 angle, side, or angle, angle, side, angle, or angle, angle, side, or HL. Again, angle, side, side is not a thing. Do not write this on your paper. All right, so example, it says 2, but it should be 1. Prove, or given that PR bisects QPS and QRS, prove PQ is congruent to PS. So what we have to do first is prove the two triangles 1 and 2 are congruent. So first, I'm going to go ahead and mark up my diagram or my triangle with what I know. So I know PR bisects angle QPS. So here's QPS. This line is a bisector. So I know it's going to get cut in half. So I can mark these as being congruent. All right, continuing on, PR bisects also QRS. So down here at QRS is another bisector. So I can mark these two as congruent. All right, and as always, you always mark your reflexive side. Any side that shares a triangle is reflexive. So notice how I've got enough information now. I've got an angle, and sandwiched between them is a side. So I'm going to be using angle, side, angle. So let's get that first part done and a proof. So we've got our given. Again, write this out. Don't just draw the line. All right, so I'm going to first start off with my angle. So angle QPR is congruent to angle SPR. And in this same line, I can go ahead and write angle QRP is congruent to angle SRP. So notice what this is saying. QPR is congruent to SPR. That's saying that these two are congruent. QRP is SRP. That's saying that these two are congruent. And the same reason applies to both of them. That's why I wrote it in one line, is definition of bisector. So if you want to write these as separate lines, that's fine. You would just have to write this twice. But you can write it as one. That's fine. All right, next I'm going to say PR equals or congruent to PR. And of course that is reflexive. Now I can say my triangles are congruent because I've got my angle, angle, and a side. But remember, it's angle, angle with a side sandwiched in between it. So it's going to be angle, side, angle. So first, let's make sure we match up our sides correctly. So we've got Q, triangle Q to P, then back to R is congruent to, opposite of Q is S. S goes to P, goes to R. So again, make sure your triangles are matched up right. QPR, SPR. They have to follow the same order. All right, so next, it wants us to prove that PQ is congruent to PS. And since we've proven the triangle is congruent, we know that everything else is now congruent as well. So it's like you've proven that 1 is congruent to 2, and you've only proven it based off 3 things. Now we know the other 2 sides and the other angle are congruent, and since that's what they're asking for, our answer is just CPCTC, which stands for corresponding parts if congruent triangles are congruent. All right, so work backward when planning a proof to show that ED is parallel to GF. Look for a pair of angles that are congruent. Then look for triangles that contain these angles. This will help in the next example. All right, so given that NO, this is the last example, example 2, don't look at that 3. Given that NO is parallel to MP and angle N is congruent to angle P, prove this stuff. All right, so first let's mark up my diagram. I got N and P. That one's pretty easy. And I've got NO is parallel to MP, so I'm going to draw my arrows here. Again, these arrows just mean parallel. They don't mean that they're congruent yet. All right, and as always, mark your reflexive side. So let me put these parallels in red so we know that these are not congruent. All right, so what these parallel lines tell you is that there's somewhere in here congruent angles because these are parallel. So what you have to do is get good at seeing where these lines are parallel. So I trace out my angle, trace out a Z, and you should see where you're starting to see congruent angles. So because of, So because of the alternate interior angles, because these lines are parallel, these angles are congruent. So I've got 2 sets of now congruent angles. We'll mark these with 2. So I've got angle, 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 side, side. So we're going to be using, in our proof, angle, angle, side. So we got all our given. All right, I'm going to say first that MO is congruent to MO because of reflexive. All right, so we've got one side stated, and somewhere up in this given statement we said N is congruent to P, so we have an angle up here as well. Now we have to figure out how we need to write this to say that NOM is congruent to PMO. So first I'm going to say angle, and this is the blue angle. Angle NOM is congruent to angle PMO. And why is that true? Well, because these lines were parallel, I knew that these were alternate interior angles, so they're congruent. So that's just alternate interior angles. All right, and so now I've listed my second angle. So let's see at the order, what the order is. I've got an angle, a side, and an angle. So I'm either going to be using angle, side, angle, or angle, angle, side. And let's see if we can do that. This angle is sandwiched between the side and the angle. So I go black angle. I've got the black angle, the blue angle, and then the reflexive side. So it's angle, angle, side. It would be angle, side, angle if the sides here were congruent. Angle, side, angle. But these just mean they're parallel. We do not know that they're congruent yet. All right. So our last step is to say that they're congruent. So using angle, angle, side, I can say triangle. I'm going to start at N, then go to O, and then back to M. It's congruent to triangle N was congruent. The angle N was congruent to P, so I had to write the P first. And notice where this blue angle is. I went from N to the blue angle, so I had to go to P to the blue angle. So I have to write M next, and then O, and that is angle, angle, side. So again, the last step now is to just prove that we've got some parallel things going on, or we got the congruent triangle. Since we know that these triangles are congruent, now we know that every single part of it is congruent as well. So now we can say MN is congruent to, oh, they want us to prove it's parallel. My bad. All right, so they want us to prove that, so ignore what I just said there. They want us to prove that these lines are parallel. They want us to prove this, not that they're congruent. So I read that wrong. So now what we have to do is figure out what angles are going to be shown that show that these is parallel. So if I trace out my Z again, I have to show that those angles are congruent. So I have to show that NMO is congruent to POM. And that is because of CPCTC. Now I can say that they're parallel because of the converse of alternate interior angles. So I can now say MN is parallel to OP. That's it.